05:45 a.m., May 26, 2025. No. A Ukrainian Air Force pilot straps into the cockpit of a MiG-29, a Soviet-era warplane never meant to carry what now clings to its wings, French-made Precision G. In just minutes, this 40-year-old jet will attempt the unthinkable launch, Western weapons at the most secure fortress in Russia's intelligence empire. The FSB, GPS guidance courtesy of the United States. Targeting software compressed, encrypted, and built in Ukraine. Strapped down, locked in tight. The pilot taxis to the runway. History presses hard against his chest. No one has ever struck an FSB facility not in this war. Their bases are bunkers buried beneath steel and secrecy. Targets once seen as untouchable until now. The flight plan is madness. Skim the treetops to stay below radar. Then pull a near-vertical climb to 5,000 meters pure suicide on any radar screen. He'll have 20 seconds, maybe less, to drop payload and dive before Russian air defenses even blink. 05:58. He pushes forward. The twin Klimov RD-33 engines scream. 18,000 pounds of thrust rip down the tarmac. The MiG surges ahead, carrying a weight that was never part of its design. At first light, this Frankenstein jet tears through the sky. French bombs, American satellites, Ukrainian resolve, all hurtling straight at Putin's shadow army. The FSB is about to find out what 3 years of Ukrainian adaptation can do. By 06:15, the MiG-29 was screaming low over Ukrainian farmland just 50 meters above the ground. At that altitude, it wasn't flying so much as skimming. Water kicked up and bent the tops of wheat stalks. Birds scattered in panic ripped from the fields by the roar overhead. Flying this low meant non-stop manual inputs. The pilot worked the stick and rudder pedals in a constant dance, weaving past power lines, cell towers, the occasional farmhouse. Exhausting, but the only way to stay off Russian radar. He had crossed the border. Every meter now pulled him deeper into the outer edge of Russia's air defense grid, specifically the S-400 system. It can detect and destroy aircraft from 400 kilometers away, so long as it has line of sight. That's where the Earth's curvature became his unlikely ally. At 50 meters altitude, radar horizon shrinks to about 25 kilometers. He flew low, fast, and flawless, still invisible. But in 3 minutes, that edge would vanish. He'd have to climb fully, expose himself. The tools he was using weren't built for a war like this. The target coordinates blinked on an iPad. Yes, a civilian tablet duct taped to the dash. It displayed a strike marker over the FSB headquarters in Glovo-Belgorod Oblast, just 5 miles from the Ukrainian border. This wasn't a depot or an ammo dump. This was Putin's old agency, the successor to the KGB, the nerve center of operations that had run countless missions against Ukraine. Now 2 French AASM smart bombs hung beneath his wings. In moments, they would speak for everything this mission set out to correct, and everything that made it necessary. French precision weapons were never meant to work with Soviet-era avionics. The MiG-29's 1980s onboard computer couldn't even comprehend GPS, let alone process satellite-guided targeting data from systems developed decades after the jet rolled off the assembly line. But Ukrainian engineers made it happen. In a Kiev workshop, they built a battlefield, workaround part ingenuity, part improvisation. Custom pylons were fabricated to carry the French AASM bombs. GPS antennas were mounted up front, feeding data through ruggedized cables routed into access panels never designed to open. It was brute force integration, French electronics patched into Soviet wiring. The AASM hammer itself is peak French weapons engineering, a guidance kit that turns a dumb bomb into a precision strike weapon. Each unit costs more than most people's homes. Its inertial guidance, supported by GPS, can steer a 250-kilogram warhead onto a screen from up to 70 kilometers out. Some variants carry a solid fuel rocket motor that ignites post-release, pushing the bomb close to supersonic speed. But all that tech is useless unless the Soviet jet can tell the bomb where to go. That's where the iPad comes in. Strapped to the MiG's dash with industrial tape, the tablet runs custom translation software. It converts modern targeting data into a format the French guidance system can read. It's digital duct tape, unorthodox, inelegant, but effective. And it's already been tested on some of the most sensitive targets Ukraine has ever dared to strike. 06:22 hours. The pilot hits the initial point. He yanks the stick hard. The MiG-29 snaps upward at a 45-degree angle. G-forces crush him into the seat. The altimeter spins out of control, 1,000. 22,000, 30,000 meters. Then all hell breaks loose in the cockpit. Radar warning receivers scream. Every air defense system in Western Russia lights up. A fighter just pierced their engagement envelope. Radar sweeps start locking in fast. An S-400 battery southeast of Belgorod comes online. Its 92 N6 radar tracks speed, altitude, and heading. Fire controls closing in, seconds away from a solution. But the pilots got one narrow window less than 45 seconds from detection to missile launch. Russian protocols aren't built for something this insane. No one climbs straight into a kill zone. That's exactly why it might work. At 5,000 meters, he hits the release point. The iPad confirms optimal launch parameters. Thumb on the release. Thunk. Thunk. 2 AASM bombs drop from the belly. No time to breathe. He rolls inverted, pulls into a steep dive. If this moment had your heart racing, hit the like button. Real tactics, real tension recreated from open source intel. A brutal high G turn, the kind you'd expect in a World War I dogfight. The MiG carves through the sky, bleeding altitude for speed. He levels out low, fast, and clean below radar coverage. Behind him, the bombs are already on their way. Their engines ignite, fast burn, sharp push. GPS receivers lock onto satellites. Inertial nav kicks in, tracking and correcting every twitch. Hundreds of micro adjustments per second. They're flying themselves now, locked onto pre-programmed coordinates, and they don't miss. The bombing maneuver the pilot just executed was a Cold War relic, a tactic born from an era when nuclear-armed strike aircraft needed to drop gravity bombs without flying directly over their targets. The logic was pure physics. Pull into a steep climb, release the bomb along an upward arc, then dive to safety as momentum carried the weapon to its destination. On paper, simple. Against modern air defense systems, borderline suicidal. But it worked. Russian S-400 batteries responded within seconds. Two 48 N6 interceptor missiles ripped off their rails, streaking skyward toward the MiG-29. But they were built to hunt high-flying bombers, not jets hugging the Earth. The MiG had already dropped back down to 50 meters, weaving violently through treetop airspace. The missiles climbed harmlessly into open sky, their seeker heads scanning for a target that no longer existed. Now, less than 2 minutes from impact, 2 AASM hammer bombs were racing toward the FSB headquarters in Glovo. No one inside knew. No alarms. No warnings. Justice was coming silent, precise, unstoppable. Guided by satellites they couldn't see and technology they couldn't comprehend. Each bomb was the product of 3 decades of precision weapons innovation packed into a 250-kilogram frame. At 8,000 meters, their onboard computers began calculations that once required an entire floor of Cold War-era mathematicians. AASM is more than a bomb. It's a fusion of systems, nose, body, tail, each solving a different problem. In the nose, the guidance module, a hardened GPS receiver paired with a ring laser gyroscope. Even if every satellite were jammed or shut down, the inertial system alone could still bring the bomb within 10 meters of its target. French engineers learned this the hard way, studying America's experience in Iraq and Afghanistan, where GPS jamming was the first move in every conflict. So they built for resilience. In the mid-body, the breakthrough. A solid fuel rocket motor. Most smart bombs glide, AASM burns. That 15-second ignition phase pushes the weapon to Mach 0.8, extends its range to 70 kilometers, and drives it fast enough to penetrate hardened targets and evade late-stage intercepts. In the tail control, sophisticated actuators adjust the fins up to 50 times per second, allowing the bomb to curve. Roll even arc back from unexpected angles. This isn't just steering, it's terminal flight choreography. And all of this French guidance, inertial autonomy, rocket power, terminal agility is made combat relevant by a Ukrainian pilot flying a 40-year-old Soviet jet. Because none of it would matter without that final link, the iPad taped to the MiG-29's dash. It runs custom translation software that converts modern NATO targeting data into a format the French bomb can read. Digital duct tape, inelegant but devastatingly effective. What's your take on this fusion of old and new? Could this kind of improvisation reshape modern warfare? Let us know in the comments. Today, that system isn't on a test stand. It's in the air, locked onto the roof of an FSB compound, seconds from impact. 0619. On Lieutenant Smirnov's radar screen, 2 fast low contacts appeared climbing hard at a sharp angle. The system flagged them as possible MiG-29s. Ukrainian. Only 40 kilometers out. He had 45 seconds. Not enough to stop what was coming, but he had to try. S-400 Triumph, Russia's most advanced air defense system, began cycling into response mode. On paper, it could take down anything bombers, ballistic missiles, hypersonics. But paper needed time. And what was inbound gave it none. The search radar needed seconds to detect and classify. The fire control radar needed more to lock and compute a firing solution. The 48N6 interceptor needed 3 more seconds from ignition to launch. Add flight time. Against high-altitude targets with predictable trajectories, it was unbeatable. Against a cold, nearly vertical bomb toss, it was helpless. OSU 26-45. 2 48N6 missiles launched. Mach 6, screaming through the sky. But they were late. The AASM bombs were already diving nearly vertical. Their radar cross-section almost zero. The fire control computer dropped the intercept probability to 12%. The missiles passed within 200 meters. Close, but not close enough. Their warheads exploded in empty air. The bombs kept coming. 0627. The first hammer smashed through the roof of the FSB headquarters in Glovo. The fuse triggered a 0.025-second delay. Not to blow the roof, but to detonate inside. 87 kilograms of high explosive vaporized in microseconds. The shockwave expanded at 8,000 meters per second. Pressure spiked over 200 psi, enough to crush anything inside. The blast ricocheted between walls and floors, tripling its force. Windows didn't crack, they erupted. Classified files, office equipment, and network gear vaporized into heat and dust. 0.3 seconds later. The second bomb struck 20 meters from the first. The building was already fractured. Load-bearing walls gone. Support columns broken. Upper floors shifting. The second warhead didn't continue the destruction, it finished it. The blast punched through the structure like an order collapse now. Engineers call it progressive collapse. The fourth floor pancaked the third. Then the fifth crashed down. Mass crushed mass. Energy fed energy. In under 5 seconds, the entire FSB headquarters, once a symbol of Russia's internal power, was gone. Just dust. Shattered rebar, secrets buried in rubble. Retribution had landed without warning. Unmistakable, irreversible. Want to see how the next mission unfolds? Subscribe. More real operations, more battlefield stories, all brought to life. Thank you.